Welcome to the Radio Revenue Podcast. Look at the shirt you're wearing right now, or maybe the dashboard of your car, or even the screen on your phone.
Yeah, it's basically everywhere.
Right. What if I told you the chemical DNA making up those products used to be a piece of dirty, discarded carpet, or, I don't know, a pile of colored plastic strapping left over from a shipping pallet?
It sounds like science fiction, honestly.
It really does. But today we are opening up a massive, freshly filed financial document. We're looking at the 2025 Form 10K from Eastman Chemical Company. And our mission for this deep dive is to figure out how a century-old company, one that started out making chemicals for Kodak camera film way back in 1920, is now quietly engineering the materials of the future.
And they're doing it literally right under our noses. When you read through a 10K like this, you realize you don't just stumble into this level of market saturation. It takes a fundamental rewiring of a company's DNA.
Which is exactly why you, listening right now, should care about this analysis. Even if you have never intentionally gone to a hardware store and bought a bucket of Eastman chemicals, you almost certainly interacted with their materials today.
Oh, absolutely.
You touch them in your vehicle, in the clothes in your closet, maybe even in the biodegradable straw in your iced coffee this morning. They are basically the invisible architecture of your day.
Okay, let's unpack this to understand what Eastman is doing today and specifically what they are building in 2025. We have to look at their radical transformation over the last 2 decades.
Yeah, because you really can't grasp their future without seeing how they intentionally dismantled their past.
Exactly. So where do we start with that dismantling?
Well, to appreciate the scale of it, we have to look at their origins. Like you said, founded in 1920 in Kingsport, Tennessee. They were essentially an industrial arm of Kodak.
Right. The film company.
Right, and they didn't even spin off as a separate public company until 1993. So for the longest time, they were a volume-based commodity chemical company, meaning they just made a ton of basic stuff.
Staggering amounts of everyday chemicals. We're talking resins, inks, polyethylene, materials that are priced by the ton and, sold by the trainload.
It's a high-volume, low-margin game.
Exactly.
But looking at the filings, starting around 2004, they made this deliberate, incredibly aggressive pivot. They looked at their massive portfolio and just started systematically selling off those underperforming commodity assets.
They really cleaned house.
They did. They got rid of the resins, they dumped the inks, they sold off their polyethylene businesses, and eventually even their PD plastics assets. It's sort of like a high-volume fast food franchise systematically selling off all its deep fryers to buy truffles and saffron.
That's a great way to put it.
They just transformed into a Michelin star restaurant. But that had to be incredibly risky, right?
Oh, it was a massive gamble. But if we connect this to the bigger picture, that shift was fundamentally about corporate survival. Well, operating as a commodity chemical company is a brutal, unforgiving business model. You are entirely at the mercy of massive price swings in global raw materials.
Ah, like oil prices.
Yes. If the price of crude oil or natural gas spikes because of a geopolitical crisis, your margins vanish literally overnight. You have absolutely no pricing power because your competitor down the street is selling the exact same polyethylene.
Right, so you're totally replaceable.
Exactly. You're abandoning the easy volume that made you billions because you want to escape that trap of being easily replaceable. So what Eastman did with the cash from selling those commodities was go on a highly strategic buying spree.
Right, I see here they acquired specialty materials businesses like Solution 2012 and Taminco in 2014.
Yeah, and specialty materials is an entirely different universe than commodities. When you engineer a highly specific patented molecule, say, one that makes a customer's end product lighter or physically stronger or more heat resistant, you embed yourself so deeply into that customer's manufacturing process that you become indispensable.
Because they can't just go down the street for it.
Exactly. You aren't just selling them a barrel of liquid anymore.
Yeah.
You are selling a proprietary solution that they literally cannot buy from anyone else on Earth.
Wow. And that strategic evolution really brings us from what kind of company they are to how they are trying to solve one of the world's absolute biggest, most intractable problems right now.
Global plastic waste.
Yes. The 2025 10K dedicates a massive amount of real estate to their bet on the circular economy, and specifically this thing they call molecular recycling.
This is the cornerstone of their 2025 strategy. It's where they are allocating major capital, They're utilizing what they call polyester renewal and carbon renewal technologies.
Okay, break that down for me. What does that actually mean?
It means they take waste that is notoriously impossible to recycle. We're talking polyester carpet, brightly colored packaging, mixed waste that gets instantly rejected by your local municipal recycler. And they're using that garbage as their primary manufacturing feedstock.
And the scale they're reaching is wild. Looking at the timeline, in 2024, they opened the world's largest polyester molecular recycling facility. Fast forward to this 2025 filing, and the output of that facility has already multiplied by 2.5 times.
The ramp up is incredible.
It is. But hold on, let me put back on this for a second.
Sure.
The 10K claims this process reduces greenhouse gas emissions by up to 70% compared to making those same materials from fossil fuels. But breaking complex plastics down to a molecular level has to require a massive amount of heat and industrial energy, right?
It does take energy, yes.
So how can a process that intensive possibly be greener than just pumping oil? And furthermore, we've been tossing plastic bottles into blue mechanical recycling bins for decades. Why is this molecular unmaking process actually necessary?
It's the essential question, honestly. To understand the environmental math, you have to understand the physical difference between mechanical and molecular recycling.
Okay, I'm listening.
So mechanical recycling, the blue bin system we all grew up with, is structurally destructive. Think of a complex plastic polymer, like a massive, intricate castle built out of Lego bricks.
Okay, a Lego castle.
Right. When you mechanically recycle that plastic, you're essentially throwing that entire Lego castle into a giant oven, melting it down into a solid, messy blob of plastic, and then trying to carve a new shape out of it.
Oh, so the structural integrity is ruined.
Completely ruined. The polymer chains literally snap during the mechanical process. The plastic loses its optical clarity, it loses its tensile strength, and its performance just drops dramatically.
So you can't use it for, like, a clear water bottle anymore.
Exactly. You can't use it for food-grade packaging. After 2 or 3 cycles, it's so degraded it just ends up in a landfill anyway. It's not a circular economy at all. It's just a delayed trip to the garbage dump.
Wow. Okay, so molecular recycling doesn't melt the Lego castle.
No, molecular recycling is the process of taking the Lego castle apart piece by piece. Eastman uses a chemical process called depolymerization. By applying specific heat and chemicals like methanol in a process called methanolysis, they literally unzip the long polymer chains back into their original individual monomers.
It's basically unmaking the plastic.
Exactly. Once they have those separated Lego bricks, they can easily wash away the dyes, the dirt, the chemical impurities, and just filter all that junk out.
Leaving them with pure, basic chemical building blocks.
Virgin quality building blocks.
Yeah.
And from those pure monomers, they build brand new polymer chains. It creates a drop-in replacement that is indistinguishable from plastic made yesterday from freshly pumped crude oil.
That's crazy.
There is zero compromise to quality. You could take a filthy dark green piece of polyester carpet, unzip the molecules, filter out the green dye and the dirt, and rebuild it into a crystal clear, sterile food-grade water bottle.
And you can just keep doing that.
Yes, in an infinite loop.
Yeah.
As for your question about the 70% greenhouse gas reduction, yes, depolymerization requires energy. But extracting crude oil from the earth, refining it, cracking it, and synthesizing it into new monomers is exponentially more carbon-intensive than just unzipping plastics that already exist above ground.
Here's where it gets really interesting, because Eastman doesn't just sell these recycled molecules in a vacuum.
Right.
They don't just ship vats of unzipped Lego bricks to people.
No, not at all.
They turn them into highly specific physical products across their 4 main business segments. Looking at the 10K, their strategy reminds me of the classic Intel Inside campaign from the 90s.
That analogy perfectly captures their market positioning. I mean, you don't buy a laptop because you love the plastic casing. You buy because of the Intel processor making it lightning fast.
Right. Eastman doesn't sell you a car windshield. They sell the ultra-thin, highly engineered layer inside the windshield.
Yeah, the interlayer.
In their advanced materials segment, they manufacture a product called SafeFlex Evoca. It's an interlayer specifically designed for electric vehicle windshields. And it's wild what it does. It provides acoustic dampening so the cabin of the EV is whisper quiet. It's optically optimized for augmented reality head-up displays. And crucially, it has advanced solar reflecting properties.
And we should pause on those solar properties because that isn't just a comfort feature. It's an engineering necessity for electric vehicles.
Because of the battery.
Exactly. If the SafeFlex Evoca interlayer keeps the cabin of the car significantly cooler by blocking infrared light, It drastically reduces the strain on the car's air conditioning system.
Right, and AC uses a lot of
A
juice.
massive amount. In an EV, the air conditioning draws power directly from the battery. So by keeping the car cool passively, Eastman's molecular layer is literally extending the maximum driving range of the vehicle.
Wow.
That is the definition of a highly engineered, indispensable specialty solution.
And they're also taking that depolymerization technology and channeling it into a product called Triton Renew.
Oh yeah, you see that everywhere now.
You really do. It's a durable, BPA-free plastic made with those molecularly recycled building blocks. It's in high-end reusable water bottles, premium food processors, even medical devices. But the segment that really surprised me in the filing was their fibers division. They have a product line called Nia and Nia Renew.
The apparel fibers are fascinating from a material science perspective. NYRenew is an apparel fiber engineered from 60% sustainably sourced biopolymer.
Which is what exactly?
It's essentially highly processed wood pulp. So 60% wood pulp and 40% certified waste plastics that went through that carbon renewal technology we talked about.
So the luxury shirt you are wearing could literally be made from a molecular combination of pine trees and an old plastic strapping band.
That's exactly what it is.
And yet the end result feels like high-end silk. It drapes like silk, it breathes, and it's completely circular.
It's incredible. And then you look at their other/innovation segment, which acts as their incubator for new markets. They have a product line called Aventa.
Right, it's the straws, right.
Yeah, these are fully compostable straws, cutlery, and food trays designed to replace single-use plastics. They are certified to break down in both home compost bins and industrial composting facilities. But the critical differentiator is that when Aventa breaks down, it doesn't leave behind microplastics in the soil.
Which is a massive regulatory focus globally right now.
Huge.
Yeah.
What's fascinating here is how Eastman approaches this kind of application development. They aren't just sitting in an isolated lab in Tennessee inventing random chemicals and hoping a market appears.
Right.
They are co-innovating directly with massive global consumer brands to solve very specific, immediate pain points.
And the cosmetics industry is the perfect example of this. The sources detailed this massive shift happening in beauty products, and Eastman's response to it is just brilliant.
It really is. The cosmetics industry is currently under intense regulatory and consumer pressure to remove non-biodegradable microplastics from their formulations.
Because they've been using them forever, right?
For decades, companies use tiny plastic spheres in sun care, skincare, and color cosmetics to give the creams that incredibly smooth, durable, spreadable feel on the skin. But those microplastics wash down the drain and end up straight in the ocean.
So Eastman saw that regulatory wave coming, and they custom engineered a solution called Esmeri. It's a naturally derived, biodegradable cellulose micropowder.
Yep.
It mimics the exact physical performance, the smooth slip, and the light scattering properties of a plastic microbead, but it's made from cellulose. It completely dissolves in the environment. They didn't just invent a chemical, they basically invented a regulatory loophole for the entire global beauty industry.
It's a perfect product market fit.
Okay, so the innovation is genuinely inspiring. They are turning old carpet into luxury clothes. They are making EVs run longer. They are pulling microplastics out of our oceans. But does it actually pay the bills?
That's the billion-dollar question.
Building molecular unzipping factories and synthesizing cellulose micropowders has to require staggering amounts of capital. We have to look at the cold, hard numbers from the 2025 10K. And honestly, the risks keeping their executives awake at night are substantial.
The financial reality is always the ultimate crucible for these green technologies. And 2025 was a demonstrably challenging year for Eastman.
How bad was it?
Well, their total sales dropped to $8.8 billion. That is a noticeable contraction from $9.38 billion in 2024. Furthermore, their adjusted EBIT came in at $930 million.
Yeah, a $500 million drop in top-line sales is not something you can just wave away with a cool story about recycled windshields. What exactly drove that massive decline?
The 10K points to a confluence of macroeconomic headwinds. A primary driver was severe customer destocking, particularly in their fiber segment, involving a material called acetate tow.
Acetate tow, which is primarily used to manufacture cigarette filters globally. But let's unpack destocking for a second, because it sounds like corporate jargon. Why would massive global manufacturers suddenly stop buying a core material?
It's a classic supply chain bullwhip effect.
Okay.
During periods of global logistical panic, like we saw in the years leading up to this, manufacturers get terrified of running out of essential materials. So cigarette manufacturers overordered acetate tow, They bought way more than they needed and stuffed their warehouses full of it just to feel safe.
Ah, panic buying.
Exactly.
Hmm.
But by 2025, the panic subsided. Those manufacturers looked at their balance sheets, realized they were sitting on millions of dollars of excess inventory, and simply stopped ordering new material from Eastman. They just burned through their existing stockpiles.
So Eastman's sales cratered not because the product failed, but because their customers were digesting a multi-year manufacturing binge.
Precisely. Add to that the general end market weakness, meaning consumers globally were pulling back on discretionary spending, buying fewer cars, fewer luxury goods, plus the ongoing friction of global tariffs, and you get a severe squeeze on sales volume.
But the volume drop is only half the equation, right? You also have to look at the cost to produce these highly engineered materials. The 10K explicitly notes that raw material and energy costs make up a whopping 45% of their total operating costs.
It's a massive expense.
Almost half of everything they spend is just buying the natural gas to heat the depolymerization facilities and the raw chemical feedstocks to run the plants. When your energy footprint is that massive, any geopolitical event that causes a spike in global energy markets hits your bottom line instantly. You can't engineer your way out of a natural gas shortage.
Which is a massive vulnerability. And the 10K outlines several other major existential risks. They specifically highlight extreme weather and climate change threatening their physical manufacturing plants.
Right, because of where they're located.
Yeah, if a hurricane takes out a highly specialized facility on the Gulf Coast, they can't just shift production to a backup plant. These facilities take years and billions of dollars to build. They also mention the constant evolving threat of cyber attacks on their infrastructure. But there's another risk deeply embedded in the filing that is particularly modern.
You're talking about the AI risk.
I am.
Let me push back on this heavily because it feels like every single publicly traded company right now is just copy-pasting the word AI into their annual reports to satisfy Wall Street algorithms. Is artificial intelligence actually a material threat to a century-old chemical manufacturing company? Or is this just a trendy buzzword their legal team forced them to include to cover their bases?
It's easy to dismiss it as a buzzword, sure. But in the context of specialty materials, it is a very real, incredibly dangerous operational threat. You have to remember how a modern company like Eastman operates today. They aren't mixing vats of liquid with wooden spoons anymore. Their entire research and development pipeline relies heavily on advanced data science and machine learning to predict molecular behaviors. They use complex AI algorithms to optimize massively intricate global supply chains and run factory automation.
So they are relying on AI not just for back office emails, but to literally invent the molecules and control the physical factory valves.
Precisely. Now, consider the risk of data bias. If the machine learning tools they are using to synthesize a new polymer are trained on flawed, biased, or inaccurate data, the AI could direct the factory to produce a chemically unstable batch.
Oh, wow.
They could literally ruin massive physical batches of product worth millions of dollars before a human even catches the error.
That's terrifying. Or worse, what about the security of the data itself?
That is the ultimate nightmare scenario outlined in the 10K. If there's a cyber breach or even a flaw in how their internal AI models handle information, highly classified proprietary formulas could be subject to unauthorized disclosure.
Oh, because of the specialty pivot.
Exactly. We talked earlier about how their entire competitive moat is based on owning the patents to unique molecules like Saflex Avoca or Triton Renew. If an AI data leak exposes the exact chemical recipes for those products to competitors in overseas markets that don't respect intellectual property laws, Eastman loses its leverage overnight.
They'd be ruined.
For a specialty chemical company, an AI data leak isn't just an IT problem. It is a catastrophic loss of their core value proposition.
So what does this all mean? When you step back and look at the whole picture from their founding as a Kodak film supplier in 1920 to this massive 2025 financial document, Eastman is basically walking a very precarious high-wire tightrope.
They really are.
On one side, they are funding incredible world-changing green innovation. They are literally unzipping plastic waste and turning it into biodegradable products and EV components. But on the exact same tightrope, they are navigating incredibly high raw material costs, massive supply chain bullwhip effects, global economic slowdowns, and the very real threats of climate change and AI data breaches.
It is a profound balancing act. They have completely and successfully shed their identity as a pure commodity supplier. They survived the transition.
Barely, but they did.
Yeah. But the specialty materials game is relentless. It requires constant, massively expensive innovation. You can never stop running because the moment you stop innovating, your specialty product becomes tomorrow's cheap commodity.
It is a fascinating, deeply complex look at the invisible engineering that actually holds the physical world around us together.
It really is. And if I can leave you with one final thought to mull over.
Wow.
We spent a lot of time today dissecting the mechanics of molecular recycling and depolymerization.
Right.
If this technology truly scales up globally, if we reach a technological tipping point where we can endlessly loop carbon and polyester back into virgin quality materials with zero degradation, at scale does the very concept of waste eventually become obsolete.
Wow.
It makes you wonder, will future generations look back at our current overflowing garbage dumps, not as environmental disasters, but as the literal, highly valuable resource mines of the 22nd century?
It was a Revenue Radio podcast. Thank you for watching. Please like, subscribe, and hit the bell to stay updated with our latest analyses.